We're on what letter? K? K? I think we did J. I think we're on K. So how do you do that one? And then L. So this is F, this is G. G, I'm going to rewrite as 2x squared plus 3x to the half, always. So today we're going to go through a few other chain rule things if I give them to you, and we're also going to go through some trig derivatives. Okay? So we're not hitting the AP stuff, we're just hitting all like curriculum right now. How do we do derivatives? Because until you get derivatives in your hand and practice them, you will make mistakes, right? Because you won't know exactly what to do. So you practice and practice and practice so that when you see you know what to do. No oopsies. All right. So F prime equals x minus 3 squared times, what the heck? 2x minus 3. And then I put it to the 1, so I remind myself that it's chain rule, and I could take an x minus 3 out, correct? And then it would be times 1, so I don't have to write that. And then G prime would be 1/2 2x squared plus 3x to the negative 1/2 times 4x plus 3. So that just stays. You can't divide the half into it. All right. So then, what's that? What's that up there? Okay. So then we get G prime of x equals G F prime plus F G prime. One term, two terms. Okay, because whenever our F prime and our G prime are chain rule, we use chain rule to get them, correct? We are going to be able to GCF every time we use chain rule, right? Also, every time we use chain rule, when we take a GCF of that out, we're always left with one of them will be gone in one of the terms and the other one will be to the power of 1, right? Every single time, because we subtracted 1 to get that chain rule to work. So, G prime of x. I'm going to take out, we could say an x minus 3 to the 1. And if you don't take enough GCFs out, you'll find out when you go to do the rest of the work. Okay, x minus 3 to 1. And then 2x squared plus 3x to the negative 1/2. I will also always, that half didn't go away, correct? It's just kind of sitting in the middle. I will always take a fraction coefficient out because it will move to the denominator when you take it out. So you guys might have not done this, but we're going to. I'm going to take the half out of these two terms as well. So I'm going to take out a half. When you divide by a half, which is what you're doing when you're taking out a GCF, it's division, right? Because if you put it back in, it would be multiplication. So when I take out a division of a half, I'm actually multiplying the other term by 2. So keep that in mind. Okay, so let's see what's left over. So I took a half out of this red term here. The only thing I'm going to take it out of is the 2. What's 2 divided by a half? Because that's how you take it out, is by division. It's 4, right? 2 divided by a half is actually 4. It doesn't just make it go away. It's not multiplication, correct? So it's 2 divided by a half, so it's 4. So I'm left, this 2 turns to a 4. This 2x squared plus 3x to the half, when I take a negative half out, what's left? 2x squared plus 3x to the 1, correct? Because it would be a half minus a half, which is actually 1. And we know they always just become 1 because of chain rule. And then the x minus 3 of the 1's gone. Then I'm left with plus, the half is out. The 2x squared plus 3x to the negative a half is out. X minus 3 squared, I took 1 out, so I'm going to be left with x minus 3. And then 4x plus 3. So do you see how the bracket inside looks a lot better since I pulled that half out? Rather than having that half weirdly in there? Okay? Then we're going to distribute. So g prime of x equals x minus 3, 2x squared plus 3x to the negative a half, and we can put a half here, and we'll deal with those in a second. In the bracket, we're left with 8x squared plus 12x plus 4x squared plus 3x minus 12x minus 9. Now, the catch here is that the x minus 3 stays in the numerator. That half, the 1 stays in the numerator, which I don't need to write, and the 2 goes to the denominator. When you have that half in front, the 2 goes to the denominator, the 1 goes to the numerator when it's in front. And then this 2x squared plus 3x can go to the denominator and go to the half. And then we're going to collect like terms in here. So we're going to get 8x squared plus 4x squared is 12x squared. Those cancel, so I'm left with plus 3x minus 9. And what can I do to this top? Take out a 3. So we're left with 3x minus 3, 4x squared plus x minus 3. Is that factor? Is this 4x squared plus x minus 3 factor? What's the matter? I took a 3 out. Did I lose people? I took a 3 out of this bracket. I got 4x squared plus x minus 3, and I put the 3 in front. Can I factor 4x squared plus x minus 3? Yes, you can factor it. It's the 4 and the 3 that are sitting out there. You get 4x squared plus 4x minus 3x minus 3 group. Take out the 4x, left with x plus 1. Take out a negative 3, I'm left with x plus 1. And so I get x plus 1 out of both terms, 4x minus 3. Coming out of 30-1, I can assume, I hope, that everyone can do decomp at this point. Beginning of 30-1, I don't feel that way, but by the end you should be able to. Because you guys even factored with trigonometry in 30-1. Okay. Yeah.
So why do you want it more factored rather than more expanded?
You want it more factored because in the next unit you're going to be getting critical numbers. So actually this particular graph, if I put it into my calculator, has maxes and mins at 3, -1, and 3/4. Because you'll set it equal to 0 and so on. Yeah.
Shouldn't 3 over 3 be 3 over 2?
That is a 2. Yeah, it should not be 3 over 3. That's stupid. So you want it as simplified as you can because these are going to be your critical numbers of your first derivative, and your critical numbers of your first derivative is when the first derivative tangent slope is 0. And the tangent slope is 0 at maxes and mins and points of inflection. So all of these spots, like I can tell you right now on this graph, 3, -1, and 3/4 are either maxes, mins, or points of inflection on the graph of cube. Because those will be the critical numbers of the first derivative, which is the whole next unit. All right. So this is F, this is G. F prime is rewrite it, ln of the base, derivative of the exponent. this is the same as 4x plus 6 to the 2/3. Whenever your bracket is to an exponent, you can't take like a 2 out. Like some people are like, well, I can take a 2 out of it. You can't. This is to this exponent. You can only take like a 2 out if the bracket didn't have an exponent on it at all. If it has the exponent 1. All right. G prime is going to be 2/3 4x plus 6 to the negative 1/3, so I'm going to subtract 1. And because I subtracted 1, when I GCF out the 4x plus 6 to the negative 1/3, the other one will become 1 every single time. And then the derivative of 4x plus 6 is 4. Make it join this. And so I get 8/3, because it's 4 over 1. I get 8/3, 4x plus 6 to the negative 1/3. Then I get f prime of x equals. Okay, G is 4x plus 6 to the 2/3. F prime is 3x squared ln 3 ln 3. Not writing what I'm writing. 2x plus f 3x squared to the g prime, which is, or times g prime. Okay. If any of our constants, or values, or coefficients, or whatever, the numbers, are a fraction, we will always take that out front so we don't have fractions within it. So let's look here. We have this, and we have this. Now, you don't have to take out the full 8/3, because the 8 isn't our issue. It's the 3 on the bottom that's our issue. Do you see that? Yeah? 8/3 there? So what we can do is we can take out 1/3. I wouldn't take out the full 8/3 because that gets really confusing. I'm going to take out 1/3 so that I can get this denominator to go away. You see that 3? That's the problem. It's going to have an embedded fraction in your weird math. So I'm going to pull 1/3 out. And then I'm also going to take out a 4x plus 6 to the negative 1/3 because I've taken the smallest one out. And then I'm also going to take out the 3 to the x squared. Now what's left over? Okay. If I take 1/3 out of this first red term, you're going to go to the 2x, because that's the one with the coefficient, right? What is 2 divided by 1/3? 6. So I'm going to, this 2x is going to turn to a 6x. The ln 3 is staying. The 3x squared is going. And what's happening with this 4x plus 6 to the 2/3? It's going to become what? 4x plus 6 to the 1. Because what's 2/3 minus a minus 1/3? 3/3. What's 3/3? 1. If you always remember to take the smallest one out, that one goes away, the other one becomes 1 every single time because you're chain ruling it. You're subtracting 1, right? So they will always combine and make a 1. So if the minus a minus making 3/3 becoming 1 doesn't work in your brain, just remember it turns to a 1. That's it. It doesn't leave a weird fraction. Because when we GCF this out, we're going to get 2/3 minus a minus 1/3, 2/3 plus 1/3, 3/3, which is what? And then the 8 stays, 3x squared goes away, and that's gone. It's just an 8. That will be able to. So, from this term and this term, we can take out a 2. So we'll get 2/3, 4x plus 6 to the negative 1/3, 3 to the x squared, 3x ln 3 times 4x plus 6 plus 4. The 3 drops to the denominator, the 4x plus 6 drops to the denominator, so I'm left with 2 times 3x squared. And then here I would get that, and then that, So I'm going to get 3x times 4x is 12x squared. Maybe we'll take more about in a second. 12x squared ln 3. And then I get 3x ln 3 times 6, which is 18x ln 3 plus 4. All over the 3 drops to the bottom, and the 4x plus 6 goes to the positive third. The ones with the fractional exponents are the ones that are most confusing. Yeah. This too? So if you look at this term here, and this term here, I could take a 2 out of both of them. There's a 6 and an 8. I took the 2 out, and then this became a 3 and a 4. If you didn't take it out here, which is sometimes more confusing to take it out here, when you get to these 3 terms down here, once you've distributed, this one will end up being 24, this will be 36, this will be 8, and then you'll see you can take the 2 out. So you could wait till this step to take it out, if that is confusing. Yeah. Yeah, you keep going. So you could take this out, it could become a 4. That is not a 3x. That's a 3x. I did say earlier that we'd be able to take more out, and then I just didn't take it out. Oops. And if they wanted to, they could write the cube root of 4x plus 6. Do the same thing. So I often wait till I've distributed everything, and then I take a GCF out. If there's a coefficient that can come up, or a constant, or a number. Coefficient. Okay. Yo.
Why are we expanding present? Why didn't you leave that factor inside that?
It's not factored.
No, I know it's.
This isn't factored.
What?
This isn't factored. This is something plus something.
I know, so.
You have to expand it first, and then if you can do decomp or product sum, you factor it down. So this one we can't do decomp or product sum because I don't know how to do decomp with a long 3 in it. So what we did last time, Nico, is we expanded it. We collected like terms, and then when we looked at it, we said, oh wait, I can factor this.
Yeah, but you could have just left it.
You always have to expand it out to see if you can factor it. So if you look at this one, if we had left this question like this, I wouldn't be able to factor that. I wouldn't have been able to get it down to here and know that these are my maxes and mins. You always, at this step, once you've taken your GCFs out, you always have to distribute through and then collect like terms. And then when you get to this point, if you can factor, you do. So at this point here, I was at the same deal as like this point here. Here I could factor, so I do. Here all I could do was take out another 2, so I did. But I can't actually factor it. So your steps when you're doing product rule is always to expand those brackets inside, collect like terms, and if you can decomp for product sum, you do, or take out a GCF, but if you can't, then you're done. Does that make more sense? Okay. Okay, Al. Okay, we're at M. Why don't you guys try this one? And then we're going to do one where it's all squared. Squared. So, when you are given, you will learn to appreciate certain questions over other questions, because certain questions are just a heck of a lot easier to do. So, for example, even though this is a quotient rule question, it is a basic chain rule, basic chain rule. You will learn to love these, because you can just take them out, and life is good. You will learn to be a little sad, but we'll practice enough so you'll be fine. The ones with radicals. Because the ones with radicals come out as fractional exponents, correct? And then you get a fraction embedded in that f plus f times g plus g times f. And so you have a little more work to do to get that fraction out, okay? But you'll be able to do all of them. So this one is actually, though, looking hard, is not. So this is f, this is g. F prime is 2, x plus 3 to the 1 times 1. Remember, I always put them to the 1. I know you don't have to, but I put it to the 1 because that screams I can take something out of this. This was a chain rule question, right? Like, trying to make my brain be like, I can take something out. Don't distribute first. Take this out as a GCF. Please stop distributing. Because you guys have, like, since grade 10 polynomials, you've been taught to distribute so much that you're just like, I'm going to start putting things into things, right? But we want a GCF first if it's a chain rule. Okay, you have like a distribution addiction. We got to like slow it down a tiny bit. Okay? G prime is 3 bracket 2x squared minus 6x to the 2. And then we're left with 4x minus 6. Which I could take a 2 out. So I can make this be 6. 2x minus 3. 2x squared minus 6x to the 2. Now the reason why, guys, I need you guys to realize this because you take stuff out when you can. The reason why we can take a 2 out of this one is what is it to the exponent of? 1. The reason why I can't take a 2x out of this one is because what's it to the exponent of? 2. Do you see the difference? Yes? Okay. All right. So let's fill in what we do know. F prime of x equals g times f prime, which is 2x plus 3 to the 1. I know it looks stupid, but I'm reminding myself I can take this bad boy out, right? Then minus, so I know the product rule from props, and in your textbook will be fg prime plus gf prime. But I will also do gf prime plus fg prime, because then it's the same as the quotient rule with a minus sign, right? So gf prime minus f g prime, this lovely term here, which seems overwhelming, but trust me, you will learn to appreciate these chain rules over any other one. All over g squared. So this is to the 3 squared. So what's it going to be to? The 6. So I will immediately write it to the 6 so that I don't go 3 and forget the squared. Do you know what I'm saying? Because it's g squared, right? So it would be that to the 3 to the 2, which is to the 6. We agree? That means I have 6 of those in the bottom. Yeah? Okay. So f prime of x, we're going to look at our two terms here. This and this. So what can I take out of the first term and the second term with coefficient-wise? I have a 2 and I have a 6. So I can take out a 2. This is still aggressively thick. Okay. Then I can take out an x plus 3 to the 1. I don't have to show the 1, but I'm just doing that for effect. And then I can take a 2x squared minus 6x to the 2, because I always take out the smallest one. Then I write what's left over. I personally put it in square brackets so that I can see that that is different than the GCFs I took out. But you could do round brackets if you're like, I am anti-square brackets. You can do whatever you want. Okay? All right. So I take the 2 out, she gone. I take out the x plus 3, she gone. So I'm left with 2x squared minus 6x. Cool. Minus in brackets, because everything behind that minus sign, this is the problem with the quotient rules. You can remember, everything behind that minus sign is going to have to change eventually. It's sign, correct? Okay. Took out a 6, we were left with a 3. We take out the x plus 3 to the 1, we're left with an x plus 3. The 2x minus 3 stayed, and that 1 to the squared is gone. Okay, right? I have to distribute that minus sign through. All to the 2x squared minus 6x to the 6. Watch this. This will always happen with the chain rule as well. I'm left with 4 down here. See how there's 2 on the top, 6 on the bottom? 4. All right. Now let's get distributing, because our next goal is always to distribute this bracket, right? We distribute that bracket, we collect like terms in that bracket. If we can do decomp, we do, or proc sum. If we can't, we can't. We're done. So we're going to get f prime of x equals 2x plus 3, 2x squared minus 6x minus, okay, I'm going to go 3x plus 9. And 2x minus 3. All over 2x squared minus 6x to the 4. Then I'm left with f prime of x equals 2x plus 3, 2x squared minus 6x, and then I'm going to get 6x squared, so I'm going to get minus 6x squared, and then I'm going to get minus 9x, so I'm going to get plus 9x, and I'm going to get plus 18x, so I'm going to get minus 18x, minus 27, so plus 27. All over that. And then f prime of x equals 2x plus 3. And I go to round brackets once I've just put these together. So 2x squared minus 6x squared, negative 4x squared. Negative 6x plus 9x is 3x. Minus 18x is minus 15x. Plus 27. And I can't factor that. Pardon? Sure, you can take a negative out and make this be negative 2 and make that be, go like this. 100% totally fine. Right? Yeah. She should have the opposite sign. Yeah. Yeah. Okay, we're going to try one where we have everything as a chain rule first. So if we look here, this is a chain rule in F and a chain rule in G when I do F prime G prime, correct? What happens if the first step, so the main thing of this one is I look at this and I say I have to do quotient rule, correct? Immediately, the first thing I have to do is quotient rule. To get F prime as chain rule, to get G prime as chain rule, but I am doing quotient rule. Will you agree? Okay. What happens if I give you n? And I give you g of x equals all right. So the previous question, chain rule was the first thing quotient rule was the first thing I needed to do. In this question, what's the first thing I need to do? Chain rule. Because I have something cubed. We agree? So let's play along, and if we use our rules correctly, we know what we're doing here. So we have g prime of x. I have to do chain rule. And what is chain rule? I take the 3, I drop it in front, I rewrite the inside, and then I reduce my exponent by 1. Correct? And then what's the chain behind that? The derivative of the inside. True? And how do I do the derivative of that inside? Quotient rule. And that's a nice quotient rule. There's no chain inside that. So I have to do quotient rule of technically 2x plus 1 over 4x minus 3. Correct? Do we agree? Okay, so I'm going to do, this is f, this is g. So I'm going to do g, which is 4x minus 3, times f prime. What's the derivative of f? 2. Minus f, what's f? 2x plus 1. Times the derivative of g. 4. All over g squared. all over g squared. Does that make sense, what we just did? We drop the 3 in front, raise to the exponent of 2, and then we have to do the derivative of the inside, just like we did before. The derivative of the inside just happens to be a quotient rule. So, we are going to get 3 over 1. And this to the 2, I can distribute the 2 to both of them. So I can get 2x plus 1 squared over 4x minus 3 squared. And the reason why I do that is so it can join the 4x minus 3 squared on this denominator. So this is multiplied by this is multiplied by, I have a 4x minus 3 squared in the denominator here. And in the numerator, I'm going to get 8x minus 6. And then I'm going to get 8x, so minus 8x, 4, so minus 4. Those cancel. And in the numerator, I'm left with 3. The full numerator. 3 times 2x plus 1 squared times what? Negative 6 minus 4. Negative 10. And then 4x to the 3 squared times 4x minus 3. Oh my gosh. 4x minus 3 to the 2 times 4x minus 3 to the 2 is 4x minus 3 to the what? 4. And then these are coefficients they can join. So we get negative 30 2x plus 1 squared It is way easier than the other version, but everyone does it wrong. Because they're like, I have to do quotient rule. They see this as a quotient rule. It's not a quotient rule. It's a chain rule. And then when I take the derivative of the inside, I have to do quotient rule. But this is a chain rule question. Okay, I'm going to get you guys to try. Oh. Go.